The legendary F-4 Phantom II fighter jet is back in the military spotlight. After various modernization and reconstruction programs were undertaken to extend its operational life. Although it first flew in the 1950s, this fighter jet is still considered one of the most formidable aircraft ever built. Now, with the support of modern technology, the reassembly process is carried out meticulously in a high-tech military engineering facility. Technicians inspect every part of the airframe, from the main frame and hydraulic system to the Phantom II's signature supersonic wings. During the modernization process, many outdated components are replaced with modern composite materials. The process begins with the assembly of the basic frame or fuselage frame. In the production area, technicians assemble the large metal frame using special, giant jigs. These jigs maintain the precise position of each part during the assembly process. The front section of the fuselage, which will eventually become the cockpit, is assembled first. One of the most complex parts of the production process is the assembly of the wings with the main fuselage. The F-4 Phantom is known for its unique aerodynamic design, with swept-back wings for stability at supersonic speeds inside the assembly hangar. The wing sections are assembled using a high-precision hydraulic system. The F-4 Phantom uses two powerful turbojet engines known for producing incredible thrust. After the reconditioning process, the engines were tested again in a special test chamber. The roar of the engines was particularly loud when the afterburners were engaged. A long flame emitted from the rear of the engines indicated full power was being generated. Technicians monitored the temperature, pressure, and stability of the engines through modern computer displays. On the F-4 Phantom production line, fuselage panels are joined using a combination of high-pressure riveting and specialized welding. Technicians work in stages to ensure all joints are tight and strong. Once the panels are assembled, the fuselage surface is inspected using a digital scanner to ensure there are no gaps or small deformations. After the structure and engine were assembled, the next stage was weapons integration. The F-4 Phantom is known for its ability to carry a variety of air-to-air missiles, guided bombs, and even ground attack rockets. In the weapons area, technicians installed missile launch rails and a modern targeting system. All systems were tested using computer simulations before the aircraft actually flew. The new radar also supports much more accurate long-range targeting capabilities. With these upgrades, the Phantom II not only serves as a historical symbol of military aviation, but also maintains its dangerous combat capabilities. This aircraft is even capable of conducting precision strike missions at night and in adverse weather conditions thanks to the latest generation of sensors and navigation systems. Furthermore, the outdated wiring and electrical systems were replaced with a modern, safer, and more efficient digital network. These changes allow the F-4 Phantom to carry the latest electronic systems without compromising its flight performance. One of the biggest changes occurred in the cockpit. The classic analog panel has been replaced with a high-resolution multifunction digital display. This technology allows pilots to obtain real-time information more quickly and accurately. A modern helmet targeting system has also been implemented, allowing pilots to lock onto targets simply by moving their gaze. The latest radar system dramatically improves the detection of air and ground targets compared to older versions. The cockpit modernization also includes the integration of a satellite navigation system, next-generation combat sensors, and a more advanced mission computer. With these improvements, the F-4 Phantom II can work alongside other modern fighter aircraft in an integrated warfare network. The engineering team completely dismantled the propulsion system before replacing critical components, such as the turbine, combustion chamber, and engine cooling system. As a result, the aircraft's performance improved and the engine's operational life significantly extended. Inside the modern assembly facility, every part of the F-4 Phantom II is inspected using digital scanning and high-precision laser technology. This technology allows technicians to detect tiny cracks or structural fatigue that are invisible to the naked eye. Industrial robots are also being used to assist in component assembly and airframe painting. This automation system makes the restoration process faster and more accurate. The engineering team then conducted a series of rigorous tests, including extreme air pressure simulations, avionics testing, and full engine testing before the aircraft was declared ready for flight. While many fifth-generation fighter aircraft have emerged, the F-4 Phantom II retains its unique place in the world of military aviation. Its aggressive shape, distinctive engine sound, and long history and numerous conflicts have earned it respect. This extensive modernization demonstrates that the Phantom I's classic design still holds great potential when combined with modern technology. This aircraft exemplifies how an old platform can be reinvigorated into an effective modern combat system. The return of the F-4 Phantom II with modern technology also demonstrates that innovation doesn't always mean creating something entirely new. Sometimes, combining the technological heritage of the past with the sophistication of the digital age can yield incredible power. With updated avionics, radar systems, engines, and weapons, the F-4 Phantom II once again represents an air force ready for modern warfare. The F-4 Phantom II is known as a multi-role fighter capable of performing a variety of missions, from air superiority and ground attack to reconnaissance. This aircraft has served many countries and proven its mettle in major global conflicts. Now, several countries are undertaking major modernization programs for their F-4 fleets. The old structure is being reinforced with new, lighter yet stronger materials. Modern avionics technology is also being installed to ensure this older generation aircraft remains relevant in the digital warfare era.